Talking about potential, we have learned just now that potential is equals to work done by charge. So remember, the SI unit of potential is volt. Remember, SI unit of potential is volt. So remember, its SI unit is volt. So the famous scientist. So let us frame the definition of 1 volt. So what is 1 volt? So you can write it like this. 1 volt is equal, see, what? What is the unit of work? Is 1 joules. And what is the charge? 1 coulomb. So now see, I'll represent you like this. Let us assume this is a conductor AB, and in order to move 1 coulomb of charge, I can write it like this. So 1 coulomb charge, I would like to move from here to here. Okay, and what is the amount of charge, or what is the amount of work we have done? 1 joules. So let 1 joules of work is done. So then we can tell then the potential difference, and we will come to that, difference of the potential between the two ends of the terminal is called potential difference. So let us do that, then I will come to this one. Okay, so first of all, remember this is A and this is B. I have told you this is a plus sign and this is a negative sign. So let the potential at A is VA. Okay, V is suffix A. And potential at B is VB. See, VA is positive and VB is negative. So I can write potential difference. You can see it like this. Potential difference is equals to, I can write VA minus VB. You can write the reverse way also. That is VB minus VA. Whatever is greater, we normally do it like this. Positive potential minus negative potential. Okay. So VA minus VB. So what is potential difference? VA minus VB. We can write that is W by Q. Now I'll form the definition here. So in order to move 1 coulomb charge, if 1 joules of work has to be done, then potential difference between the two ends of the conductor is said to be 1 volt. So I'll write it. If 1 joules of work is done in order to move 1 coulomb charge from one end to another end of a conductor, then potential difference, I am writing PD, okay, potential difference between the ends of the conductor, is said to be 1 volts. Remember, this is the definition of 1 volt. So this is potential. Electric potential, I have told you, it is the cause for which electron flows from one end to another end of a conductor. Okay. So we can write 1 volt equal to, see this point. So 1 volt, therefore I can write 1 volt is equals to Joule Coulomb inverse. Remember this one. It will be required by you in your little bit higher class, in class 12, in order to write all about the potential. Okay, and not only studying potential, current potential, you will be studying about electric potential, you will be learning about magnetic potential, all are waiting for you. So now let's continue with our discussion. So potential we have learned. Potential is the amount of work which has to be done in order to move a 1 coulomb charge from a unit charge from one end to another end of a conductor. So that's potential. And potential is the cause for what? The potential is the cause for the flow of electrons. Now what is the effect? When electron flows through the conductor, we say current is flowing. So potential is the cause and the effect is current. Remember. So in order to relate this potential and current, there is a bridge. There is a key thing which actually relates the potential difference. So let me say, so now see, I'll give you a simple example of this one. So I have taken a conductor AB, A and B. Understood this one? So I have told that this is plus 10 volts and this is minus 10 volt. So what I am actually telling? Here is a deficiency of few electrons. I am not telling you how many electrons. And here is an excess of few electrons. Okay. So when I am telling you that potential difference between the two ends of the conductor is say plus 10 volt, minus 10 volt. So one end, in the plus end there is a deficiency, and in the minus end there is an excess of electrons. Okay. So definitely electrons will flow from here to here. It's simple. Now see another condition. Same thing I am doing for another conductor. This is P and this is Q. So here the potential plus potential is say 1000 volt, and here the negative potential is minus 1000 volt. So here also electron is deficient, here is excess of electron. Now my question is, in which case the flow of electron will be greater, here or here? See here is a deficiency of, I am telling you about 10 electrons, let us assume, and here is an excess of 10 electrons, so electrons will flow from here to here. But here the deficiency is of 1000 electrons. I am telling it like that, not like that. It will be, the number of electrons will be much more higher than that one. And here the number of electrons is 1000 excess. My question is, in which case more electrons will flow through the conductor? Definitely in case of PQ, the flow of electrons will be greater. Now what is the difference between the condition I have given in AB and PQ? PQ have more potential difference than AB. What is the potential difference in AB? I can write VA minus VB as 10 plus 10 minus of minus 10. It becomes how much? 20 volts. And what about this one? Here VP minus VQ is equals, can I write it like this? Plus 1000 minus of minus 1000. So that gives me 2000 volts. So in which case potential difference is greater? In case of PQ, that is the second case. So in which case more electrons will flow? In case of PQ. When more electrons will flow, we can tell more current is flowing. So can I say it like this? So current flowing through the conductor is directly proportional to potential difference. Remember, so potential difference V is directly proportional to I. I means the current flowing through it. So this is the introduction to a new thing that is called, remember, Ohm's law. Ohm's law, a famous law. Until the next day we will be learning physics, this will be there, Ohm's law. So when all other physical conditions means, remember, pressure, temperature, these are called physical condition. So When all other physical conditions are constant, same, then current flowing through a conductor is directly proportional to potential difference. Okay, current flowing through a conductor is directly proportional to potential difference. So I can write current flowing through the conductor that is I is directly proportional to its potential difference, that is V. Here you should write one thing, provided all other physical condition. What are the physical conditions? Such as temperature, pressure remains constant. So you have learned this in class 9. So this is Ohm's law. So hope you have understood this one. More the potential difference between the conductor, more will be the current, more will be the electrons flowing, more will be the current. So we can write V directly proportional to I. So current flowing through a conductor, that is I, is directly proportional to the potential difference V, provided all other physical conditions remains constant. From here, I have told you there is a bridge between the potential difference and the current. What is that bridge? It is a new quantity that is known as resistance. So remember this one. After this line, in order to make a equal to sign here, I'll put it like this. V is equals to a proportionality constant R into I. So R is a proportionality constant. And what is the name? Every time, remember in physics, whenever a scientist invented something, they give some names to them. That name is given by that scientist. So this proportionality constant is termed as resistance. Remember, this is called resistance of the conductor. So we'll start a new thing that is called resistance. How it affects current? What is resistance? And what is the effectivity? What is the usefulness of that resistance? Why we will learn a resistance? So let us find what is the resistance and how we can deal with this one. So let us consider this is a current carrying conductor. Okay, electrons are flowing through it. So as we have learned that current is a scalar quantity, so I have told you, when electron flows through a conductor, they collide with each other. They make collisions with each other. That's why they deviate in all directions. So there is not a free flow. That is not an easy thing. Okay, electrons when moving, they face the friction, they face the collision. So there is an opposing force offered by the conductor to the flow of electron. Opposing force means the electron tries to move in this direction, but there is a force which acts in the opposite direction. This is called resistive force. What is the meaning of resistive? Which provides some resistance, which is actually opposing the flow of electron. So the force or the thing which actually opposes the flow of electrons when electrons flows through a conductor is known as resistance of the conductor. Remember, I am repeating myself. So the opposing force offered to the flow of electron, I'll write it for you. The opposing force offered to the flow of electrons by the conductor is called resistance. Remember this one, resistance. So the conductors which have more resistance is a bad conductor, because the electrons cannot freely move through that conductor, and the conductors which have less resistance is a good conductor. Why? Because they allows the flow of electron easily, as simple as that. So we prefer for our electricity chapter that the what we are using having less resistance. So what is resistance? First of all, what is Ohm's law? So we all know current flowing through the, remember this example, view it repeatedly, pause it, write it down, and remember, take the class note. That's why I am not providing the PDF or something like that. Just pause it and try to write it. This is the way you can actually 60-70% what I am teaching will be absorbed by your brain. Just try it, write it down. So this is called class note. Try to take the class note, because nowadays you are getting everything ready, like a PDF format, everything, study material. So that doesn't help. Remember my word. So try to write, and there is a chance that sir will not rub anything. So you have ample time to write. So when you are writing this, looking at me, actually you are reading that thing. And remember, after writing, after completing seeing the whole chapter, you can see that 60% is absorbed automatically, and then go through it and remember your own handwriting. It is a quickest thing to learn. Remember, read one page of a book and read one page of your own handwriting. See which one enters in your brain quickly, your own handwriting. So try to take the class note. So these two, with the help of these two examples, we have concluded that more the potential difference, more will be the current flowing, more will be the electrons flowing through the conductor, more will be the current. So V, potential difference, is directly proportional to I. So I have written it, current flowing through the conductor, that is I, is directly proportional to the potential difference, provided all other physical conditions. What are the physical conditions? Temperature, pressure, those external conditions remains same. Not temperature, I'm sorry. So that is pressure, say other things, say what I can tell. So pressure, temperature, write it down, because resistance depends on temperature. Say atmospheric pressure, color, odor, texture. Then we have introduced that V directly proportional to I. So V equals to a proportionality constant into I. So what is the name of this proportionality constant? Resistance. What is resistance? It is the opposing force offered to the flow of electrons. It's called resistance. So when electron moves through a conductor and it collides with other electrons, so actually this resists the flow of electrons through the conductor. That opposing force offered to the flow of electrons is known as resistance. So when we are talking about resistance, so let us frame the definition of resistance. Okay, so I will be defining what is resistance. So definition of resistance. So what is it? First of all, you have to frame the definition like this. You should write it like this: from Ohm's law, we have V equals I into R. I have written R into I, same thing. Or we can write R equals V by I. Okay, so now see how I am forming the definition of resistance. See here. So remember, SI unit of resistance. SI unit of resistance is ohm. Okay, and the symbol for ohm is like this. This is the symbol of ohms. So R equals 1 ohm. So I can write 1 ohm is equals to, what is the unit of potential difference? 1 volt. And what is the unit of current? 1 ampere. So I can write a conductor have the resistance of 1 ohms when the potential difference between the two ends of the conductor. So I can write VA minus VB equals to 1 volt. What is the meaning of this one? The potential difference between the two ends of the conductor is 1 volt and current flowing through it is 1 ampere. If any conductor allows this, then we can tell that the resistance of the conductor is 1 ohms. So I can frame the definition like this. If 1 ampere current is flowing through a conductor when potential difference between its two ends is 1 volt, then resistance of the conductor of the conductor is said to be 1 ohms. So remember this definition. So if 1 ampere current, so in this conductor what is the current flowing? 1 ampere. What is the potential difference between these 2 points? 1 volt. If the conductor allows this thing, that is the potential difference between the two ends is 1 volt and within it 1 ampere current is flowing, then what is the resistance of that conductor? 1 ohms. So simple as that. Okay. So remember this. Now there is an experimental setup for this finding out the resistance. You might have done this in your practical. So we will be doing it like this. So this is experimental verification of Ohm's law. So in class 10 you should have done this in your practical class. So remember, in this experiment you have to connect an ammeter which will measure the current, a voltmeter that should measure the voltage, and an variable resistance or rheostat, or in resistance box nowadays we all frequently uses that. So the circuit diagram for this will be like this. See here, I have connected one combination of cell like this, and remember, other than this on-off switch and the source, the circuit does not have any meaning. Again I am repeating, other than a source which supplies the current and a key, that is on-off switch, if you draw a circuit, no matter how much correct you are, if these two things are not there in a circuit, you will be getting 0 marks. Remember this one. So here I will put one variable resistance like this. You can put a resistance box. So this is rheostat or variable resistance. So you all know the ammeter should be connected in series. It will measure how much current is flowing through it. And here I will put an unknown resistance, the resistance of which is to be measured. So I will connect it like this. Now, in order to find the potential difference between these two ends of the resistance, what we put? We put a voltmeter across it. You might have learned that voltmeter should be connected in parallel and ammeter should be connected in series. Okay, so that is the setup. And what is our job? We have to vary this resistance and take out the value of ammeter and voltmeter. You will got to see that you will be having this type of a table, that is say ammeter reading, say I. So you should write, this is observation table, okay? This is observation table. So I am not elaborating too much about this practical work. You have to see other videos I have made for the experimental verification of Ohm's law. There I have shown you exactly the circuit connection, how to draw the graph, everything. Now it's theory, so you will be doing it. We will be doing all the things in the black whiteboard. So what is that? Observation table, you should write I in ampere. So this is it. That volt, V in volts. So you should write the values of I, and you can see that we have seen from Ohm's law V directly proportional to I. So when there is no potential difference, no current will be flowing. Say if we increase the potential difference, the current gradually increases. So I am taking it as 5, this can be 5, this is 10, this can be 10, this can vary also. Now next job is to draw the VI curve, remember. So voltage versus current graph. This is very important. In physics, remember, graph plays a very important role. Just in the next year in class 11 you will be able to see how much important the graph is. In x-axis I will put I, that is in ampere, that is the current, and this is V, the potential difference, in volts. Okay, these two. So remember, there are few things which obeys Ohm's law. There are few substances which obeys Ohm's law. Those substances are called ohmic conductor, and there are few substances which does not obey Ohm's law. Those are called non-ohmic conductor. So again I am repeating, any substance, when you are learning Ohm's law, there are two categories of substances. One which obeys Ohm's law, so that is called ohmic conductor. Ohmic conductor. What is ohmic conductor? The conductor which obeys Ohm's law. And another is that non-ohmic conductor. Non-ohmic conductor, which does not obey the Ohm's law. So we are taking ohmic conductor, which obeys the Ohm's law, because we are proving experimental verification of Ohm's law. So remember, if we do that experiment and if we plot the graph keeping current in the x-axis and voltage in the y-axis, you will see, you will be getting a straight line which passes through the origin. So in few years in ICSE they have given this thing, that what is the characteristics of the VI curve. So characteristics of the VI curve is, it is a straight line. It is a straight line which pass through the origin, remember. So it means what? The VI curve, it is a straight line passing through the origin. Remember. Now they will give you how you can find the resistance. We have to find resistance of this one. So we have drawn the graph. Now it's time to find the slope of the graph. In coordinate geometry you might have done that slope. What is slope? y2 minus y1 divided by x2 minus x1. So this value I'll tell it change in voltage, and this value I'll tell at triangle means change in current. So how to measure this? Go in this axis, go in this axis, go to this axis and go to this axis. Okay, so this is triangle V, that means change in voltage. This is triangle I, means change in current. So slope, remember, slope is equals triangle V by triangle I. So what is triangle V by triangle I? That is the resistance. So we can write this is equals R, that is resistance. So slope of VI curve always gives resistance of the conductor. Remember this. So I am here writing this slope, the slope of VI curve for a ohmic conductor. This should be a ohmic conductor. Rather than if you take a non-ohmic conductor or some gases, you will see various kind of graph, because there are many things to learn. This is just the beginning. So remember, slope of VI curve gives resistance. This is the 1 mark question. So slope of VI graph gives resistance. Remember this thing, resistance. So we are learning resistance. So very quickly we will learn one more thing here. So remember, just opposite of resistance. That means resistance is the resistive force offered to the flow of electrons. That means that phenomenon, that thing resist, does not allowing the electron to flow freely. So there must be opposite to that thing, which actually helps the electron to flow through the conductor. So there is a thing which opposing the flow of electron, and there is another thing or another concept that something is helping the flow of electron. So that is just opposite to that resistance. So remember, opposite to that resistance is called conductance. Remember, conductance. It is denoted by C. It is given as 1 by resistance. So if the resistance has the SI unit of ohms, so remember, conductance has the unit of 1 by ohm. So we can write ohm inverse, or simply another name is given mho, MH. So just reverse it, and you won't believe the symbol of ohm is this, and the symbol of mho is just opposite to this one. So that is called conductance. So opposite of resistance is known as conductance. Now we will discuss the factors which affects the resistance of a conductor. So remember, this is a very important 3 marks question. Frequently this is asked in the question paper. So there are few factors which affects the resistance of a conductor. Number 1 factor is, remember, the material of the conductor. Means it might be copper, it might be silver. So number 1 is material of the conductor. Material of the conductor. Okay, you cannot do anything with this one. So remember, the conductors which have got more free electrons, that is called free electrons theory. So you will be learning it in the later classes. So more the free electrons, so less will be the resistance, and less the free electrons, more will be the resistance. So they will conduct the electricity less, the material of the conductor. Number 2 is very important, remember. So number 2 is length of the conductor. Length of the conductor. So when you are learning physics, so it depends on this. Don't write it like that. You should write it like this, either directly proportional or inversely proportional. Okay. So more the length, more will be the resistance, because electrons have to cover more path. So let us assume, so you have to cover 1 kilometer distance and you have to cover 100 kilometer distance. Which one is tough? 100 kilometer definitely. So more the path length, more the length of the conductor, more will be the resistance. So I can write R directly proportional to L. This is very, very important, length of the conductor. Okay. So this is one. In order to increase the resistance, we increase the length of the conductor. Number 3, we can write area of cross section. Area of cross section. In some books it is written as a thickness of the wire. You can write thickness also. Thickness. Okay. So now I'll show you what is thickness. What is the cross section. So this is the pen, this is the conductor, this is the cross section. So more the thick, less will be the resistance. Now see, you are moving in a narrow road and cycling or riding a bike, and you have got a large width road, say 6 lane, 8 lane road, where your speed will be greater. In a road which has got more width, and naturally your speed will be slower when you are moving in a narrow road. So as simple as that. So more the area of cross section, more easily the electrons can flow, and less the cross section, thinner the wear, so the electrons will face more resistance. So remember, so resistance is inversely proportional to area of cross section. More the area means more the thickness of the wire, less is the resistance. Less the thickness of the wire, more will be the resistance. That's why I am giving you one. We'll learn that in household circuit. Fuse wire is a very thin wire. We can connect a thick wire in the fuse. No, we want that wire to have more resistance. And number 4 I'll tell, that is called temperature. Temperature. So remember, this is also directly proportional. So remember, this is just for your knowledge. I am writing one thing, that is temperature of a conductor. Say resistance of a conductor at T degree Celsius. Let resistance of a conductor at 0 degree Celsius is R0. Okay, let it be 1 ohm, 2 ohm, anything. And the resistance of the same conductor at T degree Celsius is R suffix T. So how this can be related to the temperature? Remember, RT, that is resistance at T degree Celsius, is equals R naught, 1 plus alpha T, or rather you can write it like this, triangle T, that is rise in temp. This is not in your syllabus. I am giving this thing for your only knowledge. Remember, this alpha is called temperature coefficient of resistance. This is called temperature coefficient of resistance. Okay, so that's how temperature affects the resistance of the conductor. So we don't want to concentrate on this one and this one. We will be concentrating on this one. So see how it works. We will be going into another thing. Remember this one. So R proportional to length, and R is directly proportional to length, and R is inversely proportional to area of cross section. So if I combine these two, I can get a relation like this: R proportional to L by A. Okay, L should be in the numerator and A should be in the denominator. Or I'll bring one constant. So R equals, so that constant I am writing as rho, L by A. So where rho is a proportionality constant. Proportionality constant. And you know the name of this constant? The rho is called resistivity. Resistivity of the new term. So remember this. This is called resistivity of the conductor. Okay. So first of all, what is resistivity? Let's see. So first of all, we are defining resistivity. See, in this equation, you have got a very important equation like this: R is equals to rho L by A. Now see what happens. If I assume L equals to 1, it might be 1 centimeter, 1 meter, anything. And area of, I am writing unit. So that solve everything. and area of cross section is 1 unit square. Okay, then see, in this relation r equals to rho into 1 by 1. This is 1, this is 1. So therefore I can write r equals rho. Now let's frame the definition of resistance. What is our resistivity? I'm sorry. So what is the meaning of this line? Say area of length is 1. So let's see how it works. So I am drawing one cube. See here. This is the cube. Let us assume this length is 1. It might be, again I am telling, it might be centimeter, it might be meter, anything. Now area of cross section is this one. This one is 1. How this can be 1? If the breadth is 1 and height is 1, then only this cross section A will be length into breadth. So A will be 1. Okay. So this is important, remember. So what is this? It is a cube. Cube of what? Cube of unit edge length. I will not tell 1. I will tell cube of unit edge length. So I will write it like this. So it is the resistance. It is, what is resistivity? It is the resistance offered by a cube of that material having unit edge length. So I will write it like this. So what is resistivity? It is the resistance offered by a cube. Why cube? Length, breadth and height is same. Or same, sorry. So it is the resistance offered by a cube of that material of unit edge length. What is unit edge length? 1 meter, 1 centimeter. So like that. Okay. So resistivity is very, so these are the few factors which affects the resistivity of a conductor. So a very important thing. Now let us find the SI unit of resistivity. So next topic we are getting into is SI unit of resistivity. SI unit of resistivity. So let's see, we will do that from this. So we should start, we have to know how this, because otherwise how many units you should remember. You can remember. There are nearly 10,000 or 20,000 units. So you have to know how to derive this. And in class 9 you are having one chapter that is called units and dimension. And in those days you don't have a value for that chapter. But in class 11 also, first chapter is units and dimensions. So you have to derive how to know this. So we are using this equation. See, R is equals rho L by A. So we want to find the SI unit of rho. So I'll write R into A divided by L. This A goes there and this L comes in the denominator. Now what is the resistance? What is the unit of resistance? It is ohm. We all know. Into area, I am taking the SI unit. So meter square divided by what is the unit of length? Meter. Cut this two. It will be ohms meter. Okay. Or we can write ohm meter. This is the SI unit of resistivity. Remember. And in sometimes this is known as, another name given to resistivity is called specific resistance. Remember, those two are same terms. So this is called specific resistance. This is called specific resistance. Okay. So we have learned the very important. This thing will be coming somewhere or other. This they definitely give this type of thing related to resistance, resistivity, SI unit, VI graph, this, that, they definitely give. So factors affecting resistance of a conductor, remember material of the conductor, length of the conductor, area of cross section. I have told you what is area of cross section of the conductor, and temperature. This thing is extra for you. Okay, this is extra. So combining these two, we have got the relation R proportional to rho L by A. So this is rho is a proportionality constant. The name of this one is resistivity. Now what is the definition of resistivity? So R equals rho, I am taking L equals 1 unit or 1 centimeter or meter, or A equals to 1 unit square. That forms R equals to rho. So what is the meaning of this line? The meaning of this line, we are talking about a cube of unit edge length. So it is the resistance offered by a cube of that material of unit edge length. That is called resistivity of the conductor. And SI unit of resistivity is how much? Ohms meter. Remember, this is also known as specific resistance of the conductor. Remember this one. And what are the factors affecting the resistivity of the conductor? Remember, this will not work then. Resistivity of the conductor is a property of a substance. It doesn't depend on length, area, cross section, nothing. So remember, specific resistance or resistivity, it is a characteristic property of a material. So remember this one very properly. They will confuse you. They will give that the length of a conductor is doubled or the thickness of a conductor is tripled. What is the effect of specific resistance or resistivity on that? So your answer will be no effect. Why? Resistivity is the material property of the material. It is nothing to do with length, area of cross section, because in order to form the resistivity we have taken all those things as one. So it is the property of a substance. Remember, I am talking about specific resistance or resistivity. It is a property of the material. Okay. So therefore it does not. It means resistivity. Again and again I am telling. It does not depends on length or area of cross section. Just keep it in mind. Okay. So as in time of resistance we have learned about conductance. What is that? Opposite of resistance is known as conductance. We all know that. Now there must be one thing that is opposite of resistivity. What is that? That should be conductivity. Okay. So next we will learn about conductivity. Remember, conductivity. What is conductivity? Remember, opposite of resistivity. Resistivity is called conductivity. I can write it like this: 1 by rho is conductivity. Now conductivity is denoted by sigma, just opposite of rho. So that is 1 by rho, remember. And what should be the SI unit of conductivity? See here, it is ohm meter. So I'll just reverse it. Ohm inverse, meter inverse. So SI unit of conductivity is ohm inverse, meter inverse. In other words, it is known as a Siemens. Okay, SIMEN. So these are the few things you have learned. This is the introductory part of current electricity. And one more thing I'd like to add here, that is called a superconductor. Remember this one. So this is superconductor. What is it? Remember one thing, when a material has no resistance, that means it does not offer any resistance to the flow of electron. That is a hypothetical case. It never happens, almost never happens. So a superconductor is the material which have infinite resistance, infinite conductance. Remember, no resistance. So superconductor means zero resistance. Zero resistance. It is never possible. If it is a metallic conductor, it is not possible. But we can tell it infinite resistance. Infinite conductance. Okay, remember this. What is superconductor? Superconductor is the substance which have zero resistance and infinite conductance. So I can give you one example to that of superconductor. Remember, it can be taken as mercury. Example I am giving, say mercury, Hg. It is Hg. Okay, so Hg below 4.2 Kelvin, below very less temperature 4.2 Kelvin. And one more example I can give you, say lead below 7.25 Kelvin. Lead below 7.25 Kelvin. So go through this in this first section of this chapter. We have learned what is current and what is potential difference, how current and potential difference are related to each other, what is Ohm's law, how to verify Ohm's law, how to find the resistance of an unknown wire, how to draw the VI curve, it is a straight line, how to find the resistance from the VI curve, what is resistance, on what factor resistance of a conductor depends, what is resistivity of a conductor, what is conductivity. We have learned that, and lastly we have learned about superconductor. So you all know this is the first portion of the chapter. Then we will start learning about terminal voltage, EMF and combination of resistors. You all know, go through this properly and take the class note. Again and again I am telling, take the class note, and you all know if you like this thing what to do. I don't mention it, so please do it. Thank you. So that is the first part of your current electricity.